Welcome back to the Math Professors. If you're looking for content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin, and today I'm going to cover some carbon dating. So let me give you a little background of my knowledge of carbon dating. Or not really just carbon dating, but half-life in general. So I was a physics major as well, and we practiced some half-lives by really using a Geiger counter and irradiating some elements. So what we would do is, say we take an element that is cesium-137. We had this big giant trash can that had a neutron source in there. So you'd send way off to the side with some jacket on, and then you'd put this thing in this neutron source, and what it would do is it would bombard that cesium with neutrons. And what it would do is it turned it into an isotope. So after, we pick like twice the half-life of its known half-life to make sure it had enough atoms in it. And then we'd pull it out of there and we'd stick it underneath the Geiger counter. Now, since the thing is now radioactive, it's going to shoot off those neutrons that it accepted. And it was really cool is when you actually looked at how many neutrons were coming off per second and just watch it on the computer, you'd see something that looks like this. And it was extremely well behaved. What I mean by that is, that looks like an exponential decay curve because that's exactly what it is, and we would find that decay curve that would match, exactly to this. So it was super well behaved. So we're going to use this idea to be able to carbon date objects. So, I'm organic, and when I eat stuff, I take an organic material, which means I'm taking in carbon-14. Now, as soon as I die, the amount of carbon-14 in my body is going to start dropping. And we know how long carbon-14, at least we know the half-life of carbon-14. So after I die, say I have 20 grams of carbon-14 in me, after 5,730 years, I'm now going to have 10 grams. And then after another 5,730 years, I'm going to have half of 10 grams, which is going to be 5 grams. So every time this time elapses, I'm going to have half of what I had before. So this will allow us to date, really when something died. Now, in this particular example, we're going to determine the authenticity of a painting, and the way we're going to do this is paintings usually use organic material to be able to create colors. So as soon as they, kill that particular plant to make, red or something like that, the amount of carbon-14 in that red is going to start decaying, and we know that it's going to take, 5,730 years for half of that carbon-14 to be left. So in order to determine the age of a painting, what we do is we take a very small sample of that painting, and we test it and determine how much carbon-14 is left in there. So if the amount of carbon-14 left is less than expected, we can really claim that painting is likely a reproduction. So let's suppose that I have this historical painting, I took a little piece off, I tested it, and I noticed that there's 93% of that carbon-14 remaining. What I want to do is I want to determine how old this painting is, knowing that the half-life of carbon-14 is 5,380. So the way this is done is we know that your A of t, or the amount after time t, is going to be equal to your initial amount times e to the kt. What I know is when t is equal to 0, this e to the kt would just become 1. So that's why we call this the initial amount. It just happens when t is equal to 0, this thing goes away. So right now we're just going to call it a of t because I don't really know the actual gram amount of carbon-14. All I know is there's 93% of it remaining. So if I want to find half-life, I really have to find this particular k, and this k changes depending on what element I'm actually testing here. So what I know is after 5,000, so let's write this as a of t, after 5,730 years, the initial amount is going to be half of what it was. So if this was 20, this would now be 10. If this was 10, this would now be 5. If this is A naught, this is going to be half of A naught, or A naught over 2. So we don't really have to know the amount, we just have to know how much of it is going to remain. So now dividing both sides by A naught is going to be equal to 1/2 is equal to e to the 5,730 times k, just reordering that. And then I'm just going to solve this for k. So the way to get rid of an exponential is we're going to natural log both sides. So the natural log of 1/2 is going to be 5,730 times k. So finally, the natural log of 1/2 all over 5,730 is going to be equal to this k. Now this is going to be the k value for any half-life. As long as you know this number, it's just going to be this denominator, because half-life means the numerator is always going to be the natural log of 1/2. So this is going to return us this particular value. So what I get for this value is going to be negative 0.0001209. Let's just say 7. That's plenty. So this is going to be that that k value for for half-life. Now I can use the information. What I know is, suppose that there's 93% of it left. So what I'm going to do is this new equation, our a of t, is going to be equal to a naught e to this k value, so minus 0.0001207 times t. So what we know is, well, actually what we don't know is we don't know t, but I do know that 93% of the initial amount is going to remain, so 93% is going to be 0.93 of the initial amount, so times a naught is going to be equal to a naught e to, that constant, times t. Canceling the a naughts, just like it happened over here. Really, the way you're going to solve this equation is identical to the way you solve this. Now the only unknown now is k. Is t. So 0.93 is going to be equal to e to that minus 0.0001207 t. We're going to natural log both sides to get rid of that e. And then divided by that constant. So the natural log of 0.93 all divided by this negative 0.0001207 is equal to t. So in a second here, we're going to figure out if this thing is a reproduction. So cross our fingers, we get 599.91 years old. So if we're looking at a painting that's supposed to be about 600 years old, we've just verified it, proven the authenticity of this painting. So if you like the content, please consider liking, subscribing, and sharing.